So today's lesson will be recorded and posted to YouTube. I see quite a few people are not here yet, which is not good. Just a couple of things too. Remember, guys, that your wellness checks are done if you're at school, right? Okay, so today I'm really excited, guys. So we're starting the final half of this trimester, right? So we're going to be doing good. So just a reminder for people that if you didn't take your midterm, you need to email and contact me. And second is that remember that everything we're doing from now on will be on the final, but the final doesn't cover the whole trimester, right? So just a heads up, right? So everything that was on the midterm won't be tested again on the final. Okay. Another thing that I want to make sure you guys know too, test scores are up. They're on Skyward, so check them out. If you have questions, you can let me know. And then yeah, this is also my last reminder that if you guys did not pass first trimester geometry, that if you get a C or higher, then you will pass both. So it's super important that you guys put in the work and get the C or higher, so that if you didn't pass that first trimester, that you can go ahead and get credit for both trimesters. Okay? All right. So does anybody have questions about anything I just said before we get started? Anybody have questions about the rest of this trimester, about anything like that, getting credit for first trimester? I appreciate the feedback. Thank you, guys. All right. Well, just remember, guys, I have office hours Monday, Tuesday, Thursday, Friday from 8:30 to 10 a.m. in the morning. So if you guys ever have questions, you can come in and ask. I would love to help you with your work and get going on that. Okay. All right. So wow. So I thought more people would be coming in, but maybe people are just like Monday, not coming to class, which is a bad choice because we're learning lots of new stuff today. Okay. So we're going to be talking about Pythagorean theorem. Now, Pythagorean theorem, guys, is so important. Oh my gosh. So I want to start with a bit of history. So you guys can just relax with taking notes for a second. But history of Pythagoras is so cool. So if you guys don't know, Pythagorean theorem comes from a guy named Pythagoras. And he is really epic. So Pythagoras was in Greece before Jesus Christ. So if you look at history, it's BC, so before Christ is what the BC stands for. But this guy was the original kind of like prophet. So it turns out Jesus is said to have done all these miracles, right? So like he turned wine or blood into wine, or water into wine. Sorry, he walked on water. Well, it turns out that Pythagoras has actually completed some of these miracles before Jesus was even born. So for example, historians have noted that Pythagoras walked on water. Okay, so as a result of this, Pythagoras had a literal cult following. So he had like a cult. So historians wouldn't call it a religion, but it was basically like he was a leader. He was a religious leader. But his religion wasn't so much based off like the 10 Commandments or a book. His kind of religion or philosophy was based off, get this, whole numbers. So Pythagorean built this cult, this religion based off that everything in the universe was made up of whole numbers. Now, for some of you guys are like, what? Like that was their thing, like whole numbers? Yeah, guys, you have to remember math was so big. Like imagine first discovering this language, math, that could describe everything in the universe with numbers. Like, so they believe that had to be God's language, right? Like, right? Because like it works everywhere. It breaks all cultures and stuff. So it's like, this has to be God's. Well, so this idea thing here, they were like, okay, so if whole numbers create the whole universe, then there must be a building block for everything. And this building block, they thought, was triangles. Okay, so this building block they thought was triangles. They thought triangles were where if you had any triangle, you can build anything in the universe. Now, it turns out they were technically correct with that assertion, that actually and it's all connected. Now, they didn't know how it was all connected, and so they're correct as we know now. So it turns out triangles are actually the fundamental building block of the universe. Now, and you guys might be like, what? And it turns out they are. Now, if you played video games, 3D graphics are actually made with triangles. And you're like, what? No, graphics like nowadays are like really beautiful and lifelike. That's because they do something with graphics cards. They increase the, quote, polygon count. And by polygon, they mean triangles because it's the easiest to compute. So when you look at a 3D model that looks smooth and stuff like that, those are all rendering tricks. It's actually just a shape made of triangles. Okay? And when you play a video game, everything you look in the universe, in that universe, is triangles. Okay? So kind of setting up. So triangles are big, but it turns out that he was correct. Triangles are the essence of everything. And we're going to talk about this today. Well, you're going to learn more about this at the end of this semester when we get into trigonometry, because trigonometry ties triangles to circles to waves. And it turns out that waves are actually the universe, right? If you've ever heard of string theory, right? So waves and quantum, that's the whole universe. So in a sense, it turns out that triangles are actually circles. What? And circles are waves. Now, if that confuses you, you shouldn't be confused. You should be like, what? Okay, maybe that is confused. Yes, it's true. Triangles are, in fact, circles. And I can prove that to you by the end of today. Okay? So, now, I'm trying to set this up. This is why this is so big. So, to understand triangles is to understand circles, is to understand waves, which means you can understand everything in the universe. It is the gateway to understanding anything and everything. Okay, so Pythagoreans believed, though, and this is where they were wrong, they believed that all triangles can be made up of whole numbers, and that's just not true. And one day, one of his apprentices came and showed Pythagorean. Well, I mean, this is historic, so historic back in that day is a little myth. Showed Pythagoras this triangle. And said, this triangle exists. Okay? You know, it might have been something easier. It might have been something like 1, 1, and root 2. And the whole point here, this is half a square. Okay, so this is half of a square. And that's why it's so important, right? So we know what a square is, right? A square is the same length on each side. Okay? And he was like, hey, Pythagoras, like I found this triangle and it's half a square and that side is not a whole number, right? Root 2 is an ugly decimal. And Pythagoras was like, you must be wrong. But this apprentice wouldn't stop telling people about it. So Pythagoras did what any good cult member would do. What do you guys think Pythagoras did? He was like, you know, apprentice, we should have a little talk one-on-one about this, right? I'll set you straight. So he was like, hey, let's go fishing together, right? Yeah, and took him out into a lake and murdered him, dumped his body into the lake. Okay, so and this is documented. This is documented stuff. So he killed him, and at that point, he was having some troubles in his cult because people were starting to question, like, hey, maybe the universe isn't made up of whole numbers. Okay? I mean, he wasn't wrong, though. Triangles are the fundamental building blocks, but we'll get to that later. Okay? Yeah, right? Who knew that math history was so juicy? Oh, you guys have no idea. I wish I could teach math history as a class. It's really juicy. So he murders this guy. Anyways, so if you guys have studied religious history, you would know that at the time, the Greeks, the Romans, they weren't really big fans of people claiming to be different religions than the one they were, right? They weren't very tolerant. So they suck out. What am I trying to say? They seeked out Pythagoras to kill him and kill his cult. And and get this, it gets more interesting. So the story goes that they were chasing Pythagoras, and Pythagoras came across a soybean farm. Okay? And it turns out the Pythagorean cult were the first historical group that were vegans. Right? So the Pythagorean cult were vegans, and he came across this soybean. I don't know if it was soybean, but some sort of bean field, and he refused to go through the field to get away from the soldiers because he didn't want to kill the plants. And so the soldiers came up and just murdered him at the edge of this field. Now it gets crazier. So like, okay, so there were these vegan mathematicians, right? Like, what's going on, right? Like, this is a good story. So in revenge, and this is recorded too, his cult went out into the countryside and just slaughtered everyone's cattle. All right. Okay, so there's the setup story for this. So Pythagorean, he got famous because he showed, okay, any right triangle. Okay. Any right triangle can be thought up of two legs, A and a C, and oops, let's get rid of this now. So it can be thought up of two legs, right? So this is a leg and a leg, and then this side is the hypotenuse. Okay, and we know it's the hypotenuse because it's always the longest side across from the biggest angle, which is going to be the 90. Okay. And what Pythagorean said is that, well, if you make each of these sides into a square, right? So B by B, so the area here is B squared. And then you make A into a square, right? So this is A by A by A, so this is A squared. And then you do the same thing for C. Oof. Right, so it's C by C by C, and this is C squared. It turns out, and I'm not going to do the proof for you today. Oh my gosh, more cool stuff about Pythagorean theorem, guys. Pythagorean theorem, so get this. This theorem there's over 200, I think, different unique ways to prove this theorem. And get this, more cool math history. One of the people to prove this theorem in a unique way, and get this, Abraham Lincoln. And he did it on a napkin while riding a train going to a speech. He came up with a unique way to prove it on a napkin, on a train, going to a speech. Okay? So, yeah, and you guys have seen this before, right? So the idea is the area of the red plus the area of the blue should equal the area of this, right? So this is Pythagorean theorem. Okay. So, I mean, like, just cool stuff, guys. And Pythagorean theorem is super important. Now, we have to remember it only works for right triangles. Only works for right triangles. Now, you're like, wait, but triangles are the fundamental building block of the universe. So why does it only work for right triangles? Well, take pre-calc and you'll learn about law of cosines, and you'll realize that, well, actually you add in a little factor and it works for any triangle, right? We're just not there yet because you guys haven't done trigonometry yet. Okay. But for right now, Pythagorean theorem only works for right triangles. Okay. So that's what we need to know. So if there was one thing in your notes, this is the most important thing. This is Pythagorean theorem. It only works for right triangles. So what we're going to do today is we're going to take this. Like, I know I just saw someone's like, hey, I learned about this in middle school. You're right, you did. So what we're going to do today is we're going to elevate this. We're going to take it to the next level. Okay, like what can we do with Pythagorean theorem? And we're going to be using it quite a bit. And I know storytelling can be silly, but everything I'm saying is historically accurate. It's cool. This math history is crazy cool, right? You have to remember, wars have been fought over math. Crazy stuff has happened over math. So Pythagorean theorem, a squared plus b squared equals c squared, only works for right triangles. Now, just as an aside, we're not going to go into this today, but remember how I said that triangles are circles, and then you guys were like, no. Well, what's the equation for a circle? And you don't need to write this down. Don't write this down, because we'll talk about this later. So what's the equation for a circle? It's x squared plus y squared equals r squared. And I don't know about you, but these look the same. And if this only works for right triangles, then guess what a circle is? It's a collection of right triangles. And that should blow your brain a little bit. Okay, so anyways, let's move on. So a circle is a collection of right triangles, right? So, and then what's a circle? A circle can be cut, and then it's a wave, and then now triangles are waves. Triangles are string theory. String theory in quantum tells us the world. Okay, cool stuff. All right, so what the heck are we going to do with all this other stuff? And I'm sorry that I'm not going to have time to go over the proof for this, but it's on the internet, and there's lots of cool ways to do it. Okay. All right. So let's go. Let's do some math. Let's finish this up today and do some math with this. See what we're going to do. Add in the new stuff, and then call it a day. How are you guys doing? Does anybody have any questions so far? Besides, like, I want to be in a cult. Don't tell your parents that. Don't be like, oh, I learned about cults today in math and I want to join one. The nighttime is the right time. All right. So the first thing we're going to do is we're going to talk about finding missing sides. Okay. So one thing that we need to remember here is that the longest side C, so the longest side C is always opposite the largest angle. Okay, so the longest side is always the opposite, I should say of the largest angle. Okay, so I did this before, but in a right triangle, the biggest angle is always going to be the 90. Okay, and then the biggest side is going to be called the hypotenuse. Okay, and if you guys want a good joke about hypotenuse, you can say, what does an airplane with someone using the bathroom have in common with a right triangle? It has a high pot in use. Kind of helps me to remember how to spell it too. So hypotenuse. Hypotenuse. Okay. All right. So let's try doing a couple of these. Oops. I have a couple of problems here that I picked out. I'm not even ready to go. Sorry for the delay. I should cue up some elevator music. Okay, so let's do an example of this. We're going to do a couple of different examples. So let's say I have a right triangle, and I have 5, 12, and x. Okay, well, it's really important to know which side is your longest side, because the C is always going to be by itself, right? So in this case, it's the legs squared, so 5 squared plus 12 squared equals x squared, okay? And then we're going to solve for x, okay? So again, this should be a review of middle school, this first part. So if you guys are like, hey, I'm rusty, I don't remember learning this in middle school, hey, that's fine. That's why we're going over it. Okay. So how do you solve this? So what I like to do it all at once in my calculator. So I'm going to teach you guys how to do that. So I don't want x squared. I want x. So how do we undo x squared? Right? How do we undo the squared? Do you guys remember? You guys did that in algebra, right? Mm-hmm. So we're going to square root both sides. Okay. Okay, so square root. Now, I hope that you remember when you take the square of a square root, you get two answers. You get a positive and a negative answer. But since we're talking about distance here, we're only going to be focusing on the positive. So again, normally you would do plus or minus, you'd get two answers. But because we're talking about a distance, the negative here doesn't make sense. So we're only going to focus on the positive. Okay? So there should be two answers, but we're only going to focus on the positive. So all I'm going to do here is I'm going to type this into my calculator all at once. So I'm not going back, typing them, going back. So I'm going to have the square root of 5 squared plus 12 squared. Right? And then that way, I only use my calculator once. I type it in, and I get 13. Okay? So that is just a basic reminder of how we use Pythagorean theorem and how we solve for squared. Does anybody have questions on this first one? And again, if you guys have questions or if I'm going too fast, let me know. I'm trying to, I know that middle school or last year, like there's been a lot of time between solving things. And so I just want to make sure you guys, if you guys have questions, right? This is just reviewing what you guys should have done at some point already. Okay. And if you're like, Kreft, I never did this. Cool. So now you're doing it. Okay, so that's an example, right, where x is the hypotenuse. Yeah, I can slow down a little bit, sorry. Okay, so this is an example where x is the hypotenuse. Okay. Now, if x isn't the hypotenuse, then we have to be a little bit more careful. So let's go ahead and draw a new triangle. And we're going to have 7, 14, and x. Okay, so this first one, right? X was the hypotenuse. It was the longest side. And I can go maybe A, B, and C. Okay, so this is where people have to be really careful with doing this, right? So we want to always identify the longest side. So the longest side, our C, our hypotenuse, is always going to be across from the 90. Okay, so my C here, right, 14 is going to be my longest side because it's furthest away from the 90. So that would mean, and it doesn't matter where you put your A or where you put your B, it's just the C is the most important. And I just want to stress that. It doesn't matter which one's your A and your B. All that matters is that you know your longest one, because the longest one is going to be by itself, right? So when I go to write this equation, it's going to be 7 squared plus x squared, and then equals, and then I have my c squared, right? So if I were going to write this out, this would be a squared plus b squared, and then equals my c squared. Okay, so again, the most important part of all of this is that the longest side, right, which is across from the 90, is by itself. Okay, so notice how we don't always just write it with x by itself, right? The x can be anywhere in this equation. So now if the x is by itself, if the x is the hypotenuse, it makes solving really easy. But if the x isn't by itself, then we have an extra step to make x by itself. Okay. So when we go ahead and solve this one, what we're going to do is we're going to have to get the x squared by itself first. Okay, so to do this, we're going to subtract 7 squared. Now, you guys might be like, well, why don't you type those into your calculator? Well, I'm a one-time calculator kind of guy, right? So I'm just going to subtract 7 squared from both sides. I'm not going to do any combining, right? You can't combine things that have different bases. So I'm just going to leave it just the same, right? So I'm not going to combine them. You can't combine them. You can't go 14 minus 7. Okay, can't do that. I just want to make sure you guys are really clear on this. You can't go 14 minus 7. You can't do that. They're not the same base. You can only combine things that have like bases. So you just keep it like this, 14 squared minus 7 squared. Okay? And then I think to myself, okay, I have x squared. Well, I don't want the square there. So I'm going to square root both sides. Now again, normally we'd get plus or minus. That doesn't matter here. We're only looking at the positive. So I'm going to go ahead and I'm going to type this all at once, one time, into my calculator. So let's go ahead and get our calculator. So again, I just took the square root of both sides. Right? The square root and the square go away. And I'm just going to type this into my calculator all at once. So let's see what we get. I'm going to get the square root of 14 squared minus 7 squared, like that. So then I'm just going to make sure, does this look like this? Sure does. I have the square root of 14 squared minus 7 squared, and I just hit enter. Okay, and for our class, we can go ahead and just type in what our calculator tells us. Okay, now if you get a decimal, that's an approximation, right? So if we get a decimal, so I would round to the second decimal. So this would be 1, 2. Okay. So on the top here, we have our exact answer. On the bottom here, we have our approximation. Okay. And then if you guys have issues with your calculators, please let me know now so we can figure it out now, right? So Desmos, I think Desmos gives you the decimal, right? So using Desmos, you're going to have to round. And I think the book always wants the second decimal. And if you guys forget about rounding, right, you always look at where you're trying to round. You look at the next one. If it's 5 or higher, you round up. So since this is 4, I just keep it as a 2. Okay. And we'll keep practicing that, right, tomorrow. We'll keep practicing that tomorrow. All right. Does anybody have questions about these two? Again, this is intended to be a review. At some time in your life, you've seen this, hopefully, and done this. If you like craft, for the life of me, I don't remember doing this. That's okay. This is just what we're going to be doing then. Okay. Why don't we go ahead and try one on our own, and then we'll move on from there. Okay. So that way, if you guys, even if you're like, I'm feeling confident, or you're not feeling confident, let's try it, see where you are. So this is a try on your own. Okay, so I'm gonna have, let's do this one. Uh, 15, 25, and x. I want you to solve for x like that, and then, right, I'll even give you a hint, right? We have a squared plus b squared equals c squared. Now let's put up a timer. I think this will take you, I'm gonna give you guys 2 minutes. Why not? Okay, and let's take a look. Let's see what we got. All right, so we're gonna go over this. If you got stuck, let's take a look at what I'm gonna do to solve this, and that hopefully will help you out. So again, with this, the first thing I'm gonna do, so this is my biggest angle. So the side furthest away, that's gonna be my C. That's gonna be my hypotenuse. So it's always the side furthest away from my 90. That's my hypotenuse, right? So that means that, again, it doesn't matter how you label them. That would be my A and my B. So I would write 15 squared plus x squared equals 25 squared. Okay, so again, my C term is always by itself. And how do you know which one's your C term? It's the one that goes, that's opposite of the 90. It's the biggest side, the biggest angle. They go together. Okay. So again, this is another one where the x isn't by itself. So if the x isn't by itself, I want to get it by itself. So I'm going to go ahead and subtract 15 squared to both sides. Again, you can't combine these. You can't combine these. So I'm just doing this all at once in my calculator. So 25 squared minus 15 squared like this. Okay, so you can't combine them. You just go ahead like this. Then I see, okay, I have an x squared. So I'm going to square root both sides, right? The square and the square root go away. I get x equals square root of 25 squared minus 15 squared. Now, again, we're not doing plus or minus here because we're looking at a distance. And distance only makes sense to be positive. So we're only doing the positive here. I'm going to grab my calculator, and I'm just going to type this in all at once. And I'm going to go. And what this does is it reduces the chance that I make a calculator mistake because I'm only doing one calculator. So I have the square root of 25 squared minus 15 squared. Okay, so I take a look. Is that what I'm doing? Yep, square root. And then I have 25 squared minus 15 squared. I hit enter, and I get 20. So it's a nice number, so I don't have to do an approximation. Okay, does anybody have questions or comments about what they did? If you made a mistake, I hope that you can see where you made a mistake. If you got stuck, hopefully you can see where you got stuck, and hopefully me talking through it helps you figure out, oh, okay, I got stuck here, but this is what I need to do. If not, does anybody have questions? Nice. People are getting it. Well done. Okay. All right. And again, guys, remember, I have office hours. So if you're just like, oh, man, I kind of got it. I wish I should have asked a question. Always come to my office hours and we can work on things together, okay? Always, always, always. I'm here for you guys. You're not on this on alone. All right. So that's finding missing sides using Pythagorean theorem, which it's helpful and it's useful, but it's not the primary usefulness of Pythagorean theorem. Okay. Now, there's some other things that I'm not going to teach this year, so I'm just going to mention them. There's something called Pythagorean triples, and that's not going to be on our exam. It's not going to be on your homework, but Pythagorean triples are just, a triple means 3. So a Pythagorean triple is 3 numbers that make a triangle. Now, do you guys remember my story, though? Remember, the Pythagorean cult only believed in whole numbers. So that's kind of the kicker. A Pythagorean triple is 3 whole numbers that make a right triangle. Now, if you've ever been in construction, they're like the easy way of doing construction. If you want a 90-degree angle, you use a Pythagorean triple because they're easy to measure. So, for example, the most famous one is 3, 4, and 5. Those 3 measurements, if you have 3 feet, 4 feet, 5 feet, that makes a right triangle. Like, there's no matter how you put them together, that makes a right triangle. But you can also scale it. So you can do 3 inches, 4 inches, 5 inches, and you'll make a right triangle, which is pretty cool. So you can make a right triangle with just a ruler. Okay, and that's used in construction all the time. All the time. I love talking to people in construction because they're going to be like, gosh, you guys use math all the time, and the first thing they'll say is, yep, Pythagorean theorem every day. Okay, but that's not going to be on the homework, not going to be on the test. They're just called Pythagorean triples. They're just whole numbers that no matter how you put them together are going to make a right triangle. Okay, which is super useful, but we just don't have time to talk about it. What we're going to talk about is classifying triangles. Just a second. Just want to make sure. There we go. Classifying triangles. That's what we are doing. So we're classifying triangles, okay, with Pythagorean theorem. So this will be on our homework. This will be on the test. Okay, so remember, a squared plus b squared equals c squared is for right triangles only. Okay, so that's the thing we need to remember. A squared plus b squared equals c squared is for right triangles only. Okay, so we can use that to our advantage. So we can use that to classify triangles. So the obvious one would be like, well, it's either a right triangle or it isn't. Now, that's really important because if you were constructing something, that's exactly what you want to do. Is like, is this square? Is this a right triangle? Okay, because so much in building, that's super important, right? So just that is super important. But there's also other things we can do. Okay, so to do this, I'm going to make a table. Okay, so let's make a table. And I'm going to have 3 parts to it. And in the middle one, I'm going to have a squared plus b squared equals c squared. And this is a right triangle. Okay, so we're going to make a table. I'm going to have three spots in my table. The first one is just a squared plus b squared equals c squared. It's a right triangle. So if you have 3 sides, right off the bat, you can know if it's a right triangle if this is true. If the 2 legs individually squared added together equals the hypotenuse squared, then it's a right triangle. Okay? So that is kind of a test, right? If this is true, it's a right triangle. And so if you ever build something, you're like, man, I wonder if this is a right triangle, you can just pull out a ruler and you can be like, hey, this is or isn't a right triangle. Okay? Hopefully you do this before you build, you know what I mean? So that way you don't have to like make a mistake. So this is the brand new stuff. So what if it doesn't equal, right? What if these 2 don't equal c squared? So the first one being is, what if a squared plus b squared is greater than c squared? So another way of thinking this, do you see how the hypotenuse is less than the legs? So what happens if this is less than, right? So c is less. Then the triangle is acute. Okay, so the hypotenuse is less. Hypotenuse is less. The hypotenuse is less. Then it's an acute triangle. Okay, so when the hypotenuse squared is less than the sum of the legs squared, then it's an acute triangle. That is, all the angles are less than 90. Okay. And then you can imagine, well, if we're going to do acute, then when c squared is bigger, right? So when the hypotenuse is more, then it is an obtuse triangle. I don't know why I wrote it down here. I had room. Okay, so that's kind of your table. Have this in your notes because, right, everything we do is open notes. So we have, if the hypotenuse is less, it's acute, and if it's more, then it's obtuse. So we're going to practice doing a few of these, right, and see how this works. Okay, and there's all sorts of applications for this, not just testing, hey, is this a right triangle, right? You might want to check, do I have an obtuse angle, right? And that's actually going to be really important moving ahead in math, right? Is it obtuse? Because it turns out some weird things can happen if it's obtuse, okay? So let's take a look. Let's do some examples of this. So Where are we? I think we're example 3. Okay. So let's do some examples of classifying different triangles. Okay. So let's say I have a triangle. And the triangle is 4.3 feet, 5.2 feet, and 6.1 feet. Okay, so just copy this down. So I have a triangle, and the sides are 4.3 feet, 5.2 feet, and 6.1 feet. Sometimes they just list it, like they just go like this: 4.3 feet, comma, 5.2 feet, comma, 6.1 feet. So you don't really even need, right? Do you guys see? You don't need the picture. You just need 3 numbers, okay? Now, this can't be a Pythagorean triple because they're not whole numbers, but we just want to know, is this an acute triangle, a right triangle, or an obtuse triangle? So we're going to classify it. Okay. So what we're going to do, so first, we need to identify our hypotenuse. So if it was a hypotenuse. So this right here is the biggest side. So that's going to be our C. Okay, so the biggest number, biggest side. Okay, so what we're going to do is we're just going to test it. So I'm going to say, okay, 4.3 squared plus 5.2 squared. And then I don't know, right, if it equals or if it's greater than less than, then I'm going to go 6.1 squared. So what we're going to do is we're going to compare them, right? We're going to compare. So let's compare these. So we're going to do the blue independently, and then we're going to do the red independently. And we're going to do this using a calculator. Okay. So the first thing I'm going to do is I'm just going to do the blues. So 4.3 quantity squared plus 5.2 quantity squared. Okay, so I'm just doing the blues. So I get 45.53. Okay, 45.53. So all I did was I took my 2 legs, individually squared, and added them together. Okay. And then I'm going to do the same thing with my long side. I'm just going to go 6.1 squared. And I get 37.21. Oh, that's confusing. Here we go. 37.21. So then we have to take a look, right? And you always look at the hypotenuse. Okay, always look at the hypotenuse. Star that. Right? It's the only one with the cool name, right? The other ones are just called legs. Hypotenuse is a rockin' name. It's a rockin' name because it's the all-star. You want to look at the hypotenuse. So look at the hypotenuse. And you're going to ask, does the hypotenuse equal this? Right? Does this equal this? And the answer is no. It doesn't. 37.21 does not equal 45.53. So you know what? It's not a right triangle. Okay? It's not a right triangle. So let's take a look again. 37.21 is less than 45.53. So which one is less? When the hypotenuse is less, this is an acute triangle. Okay. So let's recap what we just did. You're given 3 sides, you identify the biggest, and you say, okay, the 2 smaller ones squared added together, and then you look at the biggest one squared. And you're just taking a look at the hypotenuse, the biggest one, right? Biggest side is best side. So you're looking at the biggest side, and you're saying that squared, is it equal to, greater than, or less than the sum of the smaller legs squared? So in this case, the hypotenuse was less than, so it's acute. Okay, so on this next one, I'm just going to have you guys try it on your own and see what you get. Okay? Does anybody have any questions before I move on to the next one? I'm trying not to go too fast, and if I'm going too fast, I'm really sorry. I'm trying to go slow. I just get really excited about this, right? Because there's like the cult, and then like I'm just thinking like I should have my own cult, you know. Maybe I do have my own cult. Cults don't have to be evil, but mine is. All right, let's take a look. Let's have you guys try one on your own. Okay, sorry it's too fast. I'll try to go a little bit slower. And that was the reason why I am going fast, because this is review. So that's why I have been going a little bit fast, but I will slow down because this is the new stuff. So this is a try on your own. Okay. So I'm just going to give you some numbers. So we're going to say classify. Okay. So this one, I'm not going to give you a picture. I'm just going to give you 3 sides. So your 3 sides are going to be 11 meters, 14 meters, and 15 meters. Okay, so these are your 3 sides. So given those, sorry, I got to move this up a little bit. There we go. So we're going to classify that triangle just based on those 3 sides. Okay, you don't need a picture. I'm going to give you guys 2 minutes. This is just like the one we just did. So given 3 sides, we want to classify this triangle. Is it acute, right, or obtuse? All right, so that was 2 minutes. Let's take a look and go through this. If you're getting stuck, let's figure out how to get you unstuck. Okay, so I got 3 sides. The first thing we want to do is which one's their biggest side. So our biggest side is 15. That's going to be our C, which means, right, the other 2 sides are going to be your A and your B. And it doesn't matter which one's your A or which one's your B. It's just the most important is, right, C is our biggest side. So if C is our biggest side, that's going to be on its own. So we want to see if these 2 added together, right, that is 11 squared plus 14 squared, right? We don't want to just add 11 and 14. We want them squared. And then we're going to compare that to 15 squared. So I can use a calculator to do both of these, right? So we have 15 squared. I type that in. I get 225. So 15 squared is, oops, wrong color, 225. And then for the blue, I'm going to do 11 squared plus 14 squared. Okay, so I type that into a calculator, 11 squared plus 14 squared, and I get 317. Okay. Now, remember with these, right, what's important? We're always looking at the hypotenuse. Okay, so we're always looking at the hypotenuse. So we're always looking at the hypotenuse. So we got 15 squared is 200 this. So we're going to look at this one in red, right? Now, if you're not looking at it in red, just always remember, look at the hypotenuse, right? So if you don't have different colored pens, you don't need different colored pens. Just always look at the hypotenuse. So are these equal? No, they're not equal. So then we think, okay, is this greater or less? So 225 is less than 317. So if it's less, right, then it's going to be, this makes it a acute triangle. Okay, so when it's less, it's going to be acute. Okay. I want to try one more, but we're running low on time. I was going to have you guys try two more, but let's try one more. Okay. So here's the one I want. Let's try this one. Let's try 2.1 feet. Let's try 2.8 feet and 3.5 feet. So I'm going to have to go a little bit quicker on this one because we're running out of time. So I can only give you guys 1 minute to do this. Okay. So we have three sides. I want you to tell me if it's acute, right, or obtuse. All right. Oop, I muted myself. All right, so we only have a minute left, so I need to go over this. Always identify your biggest side first. Okay, so I'm going to be checking 2.1 squared plus 2.8 squared, and I'm going to compare that to 3.5 squared. Okay, so in my calculator, I grab it, and I say, okay, what's 3.5 squared? Okay, that's 12.25. And then I'm going to go 2.1 squared plus 2.8 squared, and I get 12.25. So then I set those equal to each other, like those are equal, right? So this is a right triangle, right? And Pythagorean would murder you if you found out you had done this because those aren't whole numbers. Guys, that's all I have for today. Tomorrow we're going to keep practicing these. And then we'll have time to work on our assignment. So take care, guys. I will see you tomorrow. This will be up on YouTube in just a little bit. And then take care. See you tomorrow. We're going to keep practicing this and keep going. Yep, take care.